Hello, so these next couple of videos are going to be about cellular responses to stress. So as I mentioned before, disease is a consequence of a failure of homeostasis. And when cells are put under stress, they tend to take up an adaptive response by modifying the structure or function to accommodate. Some adaptive responses being hypertrophy, hyperplasia, atrophy, metaplasia, and dysplasia. However, although there are these adaptive responses, if a cell's capability to adapt is exceeded, so if the injury is too severe, then it can undergo reversible injury, which is a change in which homeostasis is maintained, or irreversible injury, which leads to cell death in the form of apoptosis or necrosis, which we'll go on to a bit later. This can be summarised in this sort of little diagram. So you have a normal cell, it undergoes stress and it can adapt to that stress. But if the stress gets too much, it's unable to adapt and it undergoes cell injury. If this cell injury is mild, then it is reversible and it can go back to being a normal cell. But if the cell injury is severe, then irreversible damage could occur, leading to necrosis or apoptosis. In some cases as well, if the injury or stress is very severe to begin with, it can lead straight to cell injury and go to either irreversible or reversible damage. Reversible or irreversible injury. This can be summarised by this graph here. So cells rapidly become non-functional, although they're still viable. The longer the duration of the injury, irreversible injury and cell death may occur. So as you can see here, as the duration of the injury sort of increases along the bottom, the chance of it becoming an irreversible injury increases. Also, cell death often precedes ultrastructural, microscopic and grossly visible morphological changes. So cell death occurs there before them bits. But there are some key morphological features that occur with reversible injury. So for example, there is cellular swelling. This is difficult to see at microscopic level, but more apparent within the whole organism. So there's often small clear vacuoles in the cytoplasm and pinched off segments that you can see down a light microscope, but it's more apparent when you look at the whole organism. For example, if someone does a lot of sport and they've got muscle fatigue after it, this is common because of the swelling. The muscles are thicker than usual. The swelling can also cause pallor, which compresses the capillaries, increasing tugger and weight, so the muscles feel tighter. There's also fatty changes. So for example, there's changes in the lipid vacuoles found in cells involved in fat metabolism, and some other changes include changes with the plasma membrane, mitochondria, endoplasmic reticulum, and the nucleus. This is a cool histological slide that was included in my lecture that summarises nicely visually the changes between normal, reversible and irreversible injury. So you can see the normal cells, the reversibly injured cells, which shows an increase in sort of the membrane blebbing with occasional swelling, I think it is. And then in the completely irreversibly damaged cells, there's a reduced number of nuclei compared to the others, and there's fragmentation of the cells, which will cause the leaking of the contents out